Hey class, tomorrow we're taking our first test, and I'm going to go through the study team test that we took last week, just kind of as a final review. Again, this is not necessarily what the test exactly will look like. Doing well on this probably ensures that you'll do well on about 80% of the questions. 20% could vary from this considerably. For other things to look at, consider when studying, consider the closure exercises, all the exercises from chapter 3 chapter one rather, and also the pay attention to the math notes that occurred throughout the chapter. That's a good place to look also. So let's start with this test. First thing we're asked to do here is it says to examine the graph of the function f of x at right. Well, it's the graph of f of x at right. Does this relationship appear to be a function? And we would have to say absolutely yes. If I considered just this leading edge of this line, as I go through here, we can see that at no point does an x value have more than one input, right? That's, in fact, every single input x value here that I could stop at has at most one input. And, if you consider the 12 here, this value of 12, when x is 12, right, there's no input at all, right? So I would say, yes, this relationship does appear to be a function. And it says explain why, what is necessary for a relationship to be a function. I would say each input value may have at most one output. So if you have an input, it certainly doesn't have to have an output. In fact, this relationship, the domain is limited. But if there is an output, it can have at most just one output. Next, what is the domain of the function? So the domain are those x values that we can place into it. So they are x values, and they run from -3 all the way up to and including, looks like +10. So from -3 up to 10. And the next one, what is the range of this function? It looks like the smallest value we can get out of this function includes the number 0, right? When x is -3, it looks like we've got 0. So the range, the y values, it looks like it can hit 0, and it can go all the way up as high as the number +8. So that's up here at the top, right? We can get an output of 8. And then next it says, what is the value of f of 1? So when I plug 1 into this function, right, it looks like it gives me an output of 8. So I would say f of 1 is the value 8. What is f of 7? If I plug 7 into this function, right, you can see right here, that's giving me an output of 3. So when x is 7, we get, we get 3. No, no, when x is 7, we get 3. That's what I wanted to say. And then the last question says, what values of x will make f of x equal 2? What values of x will make f of x equal 2? So now it's a different question, right? Now I'm wondering what value could I put into this function so they get a value of 2 out. So if I look at this, here's an output of 2, right? That's the 2. And it looks like it's somewhere in between here, maybe -2.5. So somewhere around about -2.5. If I put -2.5 into this relationship, which is a function, if I put -2.5 in, it comes up and it gives me an output of 2. So when x is -2.5, it looks like we have an output of 2. Let's move on to the second page of the function. For the second page, we're told rather that Emma is going to simplify this expression, and we're asked to rewrite and regroup factors of this expression so that giant ones are clearly visible. So that's our first task. Rewrite it so that we can see all the giant ones. So if I'm doing that, 12 itself is 3 times the number 4. 20 is 5 times 4. And, 3 and 5 are prime, and so I'm not concerned about there being any other factors there. If I look at the x to the 5th in the numerator, I'm going to break that up as an x squared times an x to the 3rd. And the reason why I broke it up that way is because I can see in the denominator there are two factors of x, right? So clearly x squared times x to the third is the same thing as x to the fifth. And then in terms of y's, I can see that there's a y squared in the numerator. So I'm going to break up the y's in the denominator as y to the fifth power and y to the second power, because I had 7 factors of y in the denominator. So when I look at it this way, I can do my grouping here. I've got a 4. That's too wide. Let me make this skinnier than that. I'm sorry. So if I look at my numbers, I have a common factor of 4, so that's one giant 1. Also a common factor of x squared over x squared. And then finally, I see that there is a y squared over y squared. So this is me rewriting it so that I can clearly see all the giant 1s. Now, my answer, once I remove those 1s, in the numerator, I've got 3x to the third, 3x to the third power. And in the denominator, there's a 5, and there's also a y to the fifth. So that would be my final answer there. We're going to look at 3x to the third over 5y to the fifth power. Next, in number 3, we're given several problems, and we're asked to rewrite these to simplify these, right? So our answer should only have positive exponents, and if there's any giant 1s or anything that we can do to reduce the number of operations needed to evaluate, we should do that. So let's start with A. On A, I can see that I'm multiplying some factors of x, and then I've got times some more factors of x. These are negative factors of x. Well, I know from one of my laws of exponents that this would be x to the, I could write it like this, x to the 8th times x to the negative 4th. That's x to the 4th power, right? When I add 8 and negative 4, I get x to the 4th. And then in terms of my y's, I've got y squared times y to the 8th. Well, if I have 2 factors of y, I don't know why that went all the way down, 2 factors of y, and I multiply by 8 more factors of y, that's a total of 10 factors of y. So my final answer here for this would be, this is x to the 4th times y to the 10th power. For B, if a group missed this, it was just kind of because we didn't write out exactly what we have here. This 2 tells me I have 2 of these things, right? 2 of these sets of factors. And those sets of factors are a 5b to the 5th times another 5b to the 5th. Well, when I multiply 5 times 5, I get 25, right? So part of my answer is I have the number 25. And then when I multiply b to the 5th times 5 more factors of b to the 5th, I get that there's 10 factors of b. So this simplifies as 25 times b to the 10th power. The next expression, clearly there's some 1s here, so I can rewrite this 10 as 5 times 2. And I've got a 2 in the denominator also. In terms of the x's, I'm going to break this up as x to the 8th, 8 times x to the 3rd, right? That's 8, 9, 10, 11. So I'm just visually checking that x to the 11th is really the same thing as x to the 8th, x to the 3rd, and it is 8, 9, 10, 11. And then the denominator there is an x to the 8th. So you can see here, I got 2 1s, but also this is all just 1. So I'm left with an answer of 5x to the 3rd power. 5x to the 3rd power is the answer for C. And for D, most of you correctly pointed out that there are no common factors with the 12 and 7. And there's no common factors. There's no factors of x in the denominator, and there's no factors of y in the numerator. So there are no giant 1s there. So this is the simplified expression. So I'll just rewrite this as 12x to the 3rd over 7y to the 4th. Number 4 was probably one of the most missed problems, and I wish that, perhaps a good point to start would be to ask ourselves, what is this, right? Like, have an understanding of what this is. And we know from in class with our experience of a negative exponent that 2x raised to the negative 2nd power is the same thing as 1 over 2x to the 2nd power, which is the same as, if you look at it, 1 over a 2x times another 2x, which is the same as 1 over 4x squared. So just by thinking about that, I've clearly identified some of the things that this is equivalent to, right? One of the things it's equivalent to is C. You can see that's this first step I got here. Another thing that it's equivalent to is B. Clearly it is not A, right? Because it's 1 over that. So we have the reciprocal of that, and it's not negative 4x squared. Let's see, D. If I look at D, D has a common factor of 3. So I can write that as 3 times 3 times 4, or 3 over 3 times 4. And then I've got an x to the third and an x to the third times an x squared. Yes, I do. And you can see that there's a 1 in the form of 3 over 3 and x cubed over x cubed. So what I'm left with is the top is the number 1 and the bottom is 4x squared. So this is the same also. So we've got B and C and D are the same. The other one that we're not sure about is this. I do know that the square root of 4 is 2, and the square root of x to the 4th power would be x squared. So this actually becomes 1 over 2x squared, and we need this to be a 4, and it's not, it's a 2. And how do I know that's the square root? Remember the kind of the definition. If I multiply 2x squared by 2x squared, I get exactly this thing inside. So this has to be the square root. Just like if I said, hey, the square root of 9 is the number 3. Why? Because 3 times 3 is this 9. So this is the square root. Same thing here, 2x times 2x is 4x squared. So for this problem, the only equivalent expressions were B, C, and D. Okay, so let's move on to 5. 5 we're asked to solve. When we're asked to solve for something, we're asked to find the solutions, right? Not how many solutions there are. I'm asking what actually are the solutions. So let's start with part A first. And most of us, this is clearly a skill learned elsewhere, not necessarily in my class, but most of you did write this as 4x plus a 4. And on the other side, I've got 3x minus 5. I can combine the 4x and the 6x, so this becomes 10x. And I can also combine this 19 and the 4, 19, 20, 21, 22, 23. So 10x plus 23. On the other side, we still have the 3x and the minus 5. If I continue here, let's go ahead and I guess I can take away 3x from each side. So this side is going to become 7x if I take away 3x. And the other side is just going to become negative 5. And then if I take away 23 from each side, this will become 7x is negative 28. And in the last step, if I divide both sides by 7, I get that x is negative 28 over 7. And that happens to reduce, right? That is the same thing as negative 4. So x is negative 4. For problem B, solving for x here, this is going to become 10x plus the number 6 is equal to 6 times x minus 3. If I take away 6 x's from each time, this becomes a 4x over here. And then if I subtract 6 from each side, this becomes 4x is negative 9. And then as a final step, I'll just divide both sides by 4. X is negative 9 over 4. There's no common factors there, so I wouldn't reduce that fraction. I would just leave my answer as negative 9/4. For C, on the left-hand side, this is equivalent to 6x minus 3 plus 5, which is the same thing as 6x minus 8. And over on the other side, I have, oh, that's ridiculous. I don't know why this is negative 8. If I combine negative 3 and 5, I don't get negative 8. Negative 3 plus 5 is a positive 2. You see, sometimes I put the brakes on and slow myself down. Negative 3 and 5 is 2. On the other side, if I combine this 4x and the 2x, I get 6 times x. Geez, Roberts, actually -3 and +5 is +2. -3 and 5. 5 minus 3 is 2x. Yeah. And then on the other side, this is +2. You know, it is late in the afternoon. It's probably nap time for Mr. Roberts. So, um, and then finally for this problem, I noticed that both the left and right hand side are the same. And when I see that I get two things, you know, that are always going to be equal, like for example, if I take away 6x from both sides, I get that 2 is 2. This statement's always true. And because this statement's always true, that means it doesn't matter what value of x I selected. All real numbers are solutions, right? What are the solutions? I can pick any number I want and plug it in there. So important. Yes, there are an infinite number of solutions, but I didn't ask you how many. I said, what are they? So the solutions are the real numbers, right? Any value you can think of, put in there, it would work in that original equation. And then finally for D, let's see. I'm going to, I'll combine these. So this is a 3x plus 12 on this side, right? 2x and x is 3x, and 2 plus 10 is 12. On the other side, I've got -3x minus 5. I'm going to add 3x to both sides. If I do that over here on the left-hand side, this is going to become -5. And on the right-hand side, when I add 3x, I get 6 times x plus 12. And I'm going to divide or subtract 12 from each side. -5 minus 12 is -17. That's 6 times x. And then if I divide both sides by 6, I get that -17 over 6 is what x is. Again, there's no common factors there. It can't be reduced. So this is really just the preferred answer. Just leave it as this improper fraction. Let's see. For question 6, we're given two functions, function f and function g, and we're asked to evaluate them kind of in isolation and then do two of them together. So for A, this says what is f when you give it the value 3, right? What is f of 3? Well, f of 3 is equal to 3. F of 3 is equal to 3 times 3. That's me putting in a 3 for x, and then plus the number 5. 3 times 3 is 9, plus 5 is 14. So when I give this function 3, it gives me back 14. Let's do C since we're here. For C, if I put in 0, this is going to become, well, 3 times 0 plus 5. So if I give this function 0, it's going to give me the answer of 5 back. So f of 0 is 5. For B, it says, what's g of 2? Okay, so particularly when you're squaring things, be careful with this. So g of 2, right, I get 2 minus 4, and I'm going to square that. 2 minus 4 is -2. 2 minus 4 is -2. So I have -2 squared. And of course, to square a negative number means that I multiply it times itself. That's what it means to square any number. So -2 times -2 is +4. So in this case, I've got +4. Last question. It says, what do you get when you add f of 3 with g of 9? Well, f of 3, I've already done. That was part A. Now, because it's going to be part of another problem, I might want to double check. If I put 3 in here, 3 times 3 is 9, and 9 plus 5 is 14. So that's going to work. So this will become 14 again. I already did that in part A, plus g of 9, which is what? 9 minus 4, quantity squared. 9 minus 4 is 5. So this is 14 plus, I'm evaluating inside the parentheses first right here, right? 9 minus 4 is 5. I'm going to square that. 5 squared is 25, so I've got 14 plus 25, which is 39. So for D, we get a value of 39. All right, last page. It says create a table, okay, a graph, okay, and an equation to match the tile pattern below. Sketch figure 0 based on the pattern I see. So what I'm seeing here is every single time I move forward, it looks like I'm adding these one on each corner. Adding here, 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 and here. So if I take that backwards, right, and I take those away, I end up getting figure 0 as just a single tile. So I can see here, where am I starting? I'm starting at 1. Oh, this is funny. This is kind of chapter 2 also. I'm starting at 1. And how am I growing? My growth is plus 4. So if I was to write this as a table, figure 0, 1, 2, 3, 4, 5, 6, my goodness, 7, 8. Figure 1 had 1, and then I went to 5 because I had 4, and then 9, and then 13. What am I adding for? And then 17. 17 plus 4 is 21. 21 plus, if I keep going, 21 plus 4 is 25. I don't know this far. This would be 29, and 29 plus 4 more would be 33, right? Yeah, 33. So that's my table for this situation. The equation would be y, the number of tiles, is equal to 4 times the figure number plus my starting point at 1. The 8th figure, oh, I got it here, right? But also, just as a double check, if I put 8 into there, 4 times 8 plus 1, that's 32 plus 1, that is 33. So I can see I've clearly got that. And then the last one says to create a graph of it. This graph is scaled poorly. I don't like this. I'm going to say that this is 0. I'll say that this is figure 1, 2. Why am I 1, 2, 3? And you did not have to space it out like that. And I don't know actually why I'm spacing it out like that, but I'm just trying to use more of the graph. I start with just one tile, right? So I'm gonna make these all each worth 1. So I start with one tile, and I'm gonna go up by 4, right? So I can see on my table when x is 1, I should be landing at 4. So here I should be at 1, 2, 3, and 4, and then I'm gonna go up 4 more. 1, 2, 3, 4, and then I'm gonna go up 4 more at the 3. 1, 2, 3, 4. Oh, that's so nice. 1, 2, 3, and 4. That's so nice because look at it, it's all so linear, huh? I don't know that I necessarily should graph those or connect the dots. I guess I could, but I'm thinking really I don't have figure numbers in between. So either way is fine for now. We'll talk more about that later. And then finally, write some numbers in scientific notation. So my advice is always to, first of all, place the decimal point where it should be, right? Remember, scientific notations are numbers that are the product, factors of two numbers. One of them is greater than or equal to 1, but less than 10. So I have to have a number in that range. It's greater than or equal to 1, and it has to be less than 10, and then times some multiple of 10, some factors of 10. So this is 5.2. Now, in order for that's not the number I have above, is it? Right? No, it's clearly not. So I have to take this number that I have, and I have to divide. If my decimal's here, I have to divide by 10s to make it smaller. So if I take 5.2, this number, if I take the 5.2 and I divide by 10, it's here. If I divide by another 10, it's here, another 10, and another 10. So I have to divide by 1, 2, 3, 4 tens. Remember, dividing by 10 is the same thing as multiplying by 10 to the negative 1. So I have to multiply by 10 to the negative 4th power, because that's me dividing by 10 4 times. So in this box right here, we should write 5.2 times 10 to the negative 4th power. The next one, I have 2.8. I have 28,000. So the decimal's here, but that's not the number I have, is it? The number I have is much larger. So I need to multiply by some 10s to make this be the same number. So again, if I have it here, I have to multiply by 1 10, 2 10s, 3 10s. Oh, I have to multiply by 4 10s, but getting larger, right? So 2.8 times 10 to the 4th power would make that 2.8 grow up to be 28,000. Oh, yeah, it would. Yeah, it would. 2.8 is going to become 28. It's going to become 280. It's going to become 2,800. Then it's going to become 28,000. Yeah. And then the last one here, I've got a number that's, it's not quite in scientific notation, right? So my goal, kind of similar, I'm going to say I'm looking at 1.235. Now, this number right here that I've underlined in green is not 1.235, right? I need to multiply by 10 twice. So times 10 to the second. So now this thing that I've underlined in green, this whole thing is exactly 123.5, right? Move it over once, that's 12.3, move it over again, that's 123.5. Now what I got to do is I got to multiply that times 10 to the fifth power. Okay, so looking closely at this, what do I have? I have 1.235 times 10 to the seventh power. And it turns out that that is this number written in scientific notation, 1.235 times 10 to the seventh power. So that's it for this. I hope you found that a little helpful, and under 30 minutes. Good luck tomorrow on the test. Rest well, maybe eat a good breakfast, and I'll see you in class.